So the first thing I want to say is that if you notice, I posted exam 2. If you haven't had a chance to look at that, make sure you take a look at it and take note of the due date for exam 2. So exam 2 is based on the garage door program that you did for a previous lab. The other thing is exam 3 will be due at the end of the semester, and probably in a couple days I'm going to activate that also. That's more of a research project, and you look at a PowerPoint, do a little bit of research on the net, and answer some questions, and that's going to count as an exam. So the only other written exam that we have for the semester, as I promised you, was exam number 4, and that's based on the material we've been talking about last week, and we'll continue to talk about this week and then to next week. So today, what we'll do, we have one more lecture. It's kind of the follow-up from the KMAP stuff that we talked about. We have one more lecture, and then we'll get into the part of the class where we kind of pull all this stuff together, and it'll start to make sense. So if you have this handout that I'm displaying, it will be nice. You don't have to have it. I'll display it here on your screen, and I'll also put some stuff on the board. But you do want to have pen and paper. You want to have pencil, pen, paper, because we're gonna do some figuring of some circuits here. And I want to start by looking at the terms on this sheet. Now these are very important, so you might want to just jot these down and become familiar with these terms. And there's some specific terms on here that we're gonna need to carry over into the next lecture. So I'll talk about what those are. So let's talk about these vocabulary words, these terms. And the first one is variable, a variable. So a variable is a letter used to represent the input of a gate. So you've all seen that before. Maybe we have an AND gate. See if I can draw an AND. We might have an AND gate, and we use X for the output, or Y or Z or something like that. And then over here we have the inputs. So I might have an A and I might have a B. So these are variables. A variable is just a letter of the alphabet that we use to represent the input or output of a logic gate. A complement is a variable that's been knotted. So if I take this A and I put a bar over it, then that's a complement. Or I can actually express it another way I mentioned before, that instead of using the bar, you can use the prime symbol. So I can put a little mark like that. So either way, whether you do it with the bar or with the prime symbol, that's called a knot or not A. And when you knot a variable, then you have what you call a complement. A literal is a variable or its complement. So a literal refers to both the complement and the variable. Now this summing is sum and product. The sum term and product term. So let me just get off the camera. Let me go to the camera for this. Get off camera. So the sum term and the product term. It's just what you think they are. If I have a sum term, then basically I'm just taking two literals and I'm ORing them together like that. So that's a sum term. If I have a product term, I'm taking two literals and I'm ANDing them together like this. So a sum term, sometimes we'll put it in parentheses to make you think of a term. So a sum term basically is just, we're just ORing OR term. I said that wrong. So sum term we're ORing, and then here we're ANDing. So product term we're ANDing. Now what you want to remember about these two, the sum term and the product term, and I'll come back to this later, but what you want to remember is that when you have a sum term it always evaluates to a 0. And when you have a product term, this always evaluates to a 1. And that's by definition. So by definition, a sum term will evaluate to a 0, product term will evaluate to a 1. Then what you can have is you can kind of put these together, the two forms. The first form is called the sum of products, or SOP, sum of products, and the other is product of sum, POS. So what does this look like? The sum of products, well, just what you think. I might have more than one product term. Maybe I got something like this. And when I OR them together, then I have a SOP. Or I might have product terms. Maybe I got something like this. And the fact that I'm ANDing those together, that's a POS. So I'm going to have an SOP, sum of products, or POS, product of sums. And the one actually that's important for what we're going to do in this class is this one. Then we'll talk about that in detail. We'll mention this a little bit, show you what you can do with that, how it kind of applies to gates and the truth tables and all that. But the one that we make use of in this class is the SOP, so that's what's important. So going back to the handout, you want to make sure that you're familiar. Variable, complement, literal, sum term. Remember that a sum term and a product term, ORing and ANDing. Sum term evaluates to a 0, product term evaluates to a 1, and then we have the sum of product and product of sum. Now the domain, is just the list of uncomplimented literals in a term. So the domain is a list of uncomplimented literals in the term. So if I go back to the board again. So like for this one, the domain would be just a list of literals. So I usually write a D and then a colon to represent domain. And then you just list them with commas. So I have in this term I have an A. In this term I have a B. Of course, you just list it once. Then I have a C. So the domain of this expression is ABC. Over here, the domain, well, I got, now notice that A is knotted, but I want the uncomplimented literal. And so I want to, even though it's knotted, I'm not gonna show a knot in the domain. I'm just gonna show it as A, will be B, and then D. So the domain is just a list of the literals that are uncomplimented. And so if something appears in the complemented form, when you list it in the domain, you just show the uncomplimented form of that literal. As I said before, though, what's important for us is the SOP form, the sum of products. And remember, each term of a SOP, by definition, evaluates to a 1. And the reason is right here in this box, is that the SOP form of logic is what's used on each rung of a ladder in the ladder diagram. And so that's why this is specific to the PLC, and it's important for the PLC. Now you want to take note of one thing, and that's this sentence I have right here. When you're dealing with SOP form, you can have each individual variable knotted like this, but you're not allowed to have a bar across more than one variable. So this is not allowed right here. You might think to yourself, okay, well, what if we have that? What do I do about it? Well, remember, break the line and change the sign. You demorganize it. So don't worry about that right now. We'll kind of come back to that. Just know that you're not allowed to have the not sign over more than one variable when you're dealing with this form and PLCs. That's specific to PLCs. Well, how would I represent using logic gates an SOP? And here's an example of it. Of course, I got a product, so I first got to get the product. What I mean by product is just ANDing. So ANDing is what we call binary multiplication. ORing is like binary addition. So I got to have some AND gates. So I got 3 AND gates here. I'm going to OR them together, and the output of that, of course, be an SOP, and the output's like right here. So that should make sense to everybody. I haven't said anything so far that's earth-shaking. Now, what we got to be able to do, though, is relate this to basically what you'll do in the PLC, and we have to also be able to relate this to the truth table, because the truth table ends up being one of the tools that we use to design our program, our logic program. And we'll get to that, not today, but you'll see the connection here starting later in the week. So there's 2 kind of SOPs. There's a standard SOP, a standard sum of products, and then there is a non-standard sum of products. And so here's an example over here. Here's a non-standard SOP. And here's a standard SOP. So how does a non-standard SOP differ from a standard SOP? So a standard SOP will have every member of the domain in each term. I want to say that a second time. A standard SOP will have every member of the domain listed in each term. So if you look at the standard, well, either one of these, really, the domain here, if I list the domain is A, comma, B, C, and D. And excuse me, guys, I'm drawing with my mouse, so that doesn't work out that well. So here's a list of my domain for both of these expressions. But the one on the left is not standard, because in that first term, there's just the A. The B, the C, and the D are missing. In the second term, there's a B and the C, but the A and the D are missing. And in the third term, there's just the D, the A, B, and C are missing. So I'm missing terms from each one of those. I'm missing variables for each one of those terms. Whereas the one on the right, each term has every member of the domain. And so the standard SOP is what's important for us in this class. Well, what if we're given a non-standard SOP? What do we do about it? Well, that's part of what I want to talk about today. So one thing you got to be able to do is take a non-standard SOP and convert it to a standard SOP. So how would we do that? So let's talk about that. Converting a standard SOP to a non-standard SOP. So to do that, we make use of 2 of those, those Boolean laws and rules that I gave you a list of. We make use of that, a couple of those rules on there. And specifically, the 2 that we make use of, one is this one. The fact that if I take a variable and I OR it with this complement, I do that, what do I get over here for an answer? If I OR something with this complement, then what do I get on the right side of that equal sign? Anybody? A can take on the value of either 1 or 0. So if I let A equal binary 1, that means not A has to be a 0. And a 1, if I OR that with a 0, I get a 1. If I reverse it, if A is a 0, that means the complement of A is a 1, and I'll get a 1 back either way. So anytime, and this is important, anytime you OR a variable with this complement, you always get a logical 1 back. So that's one rule that we'll use to help us convert a standard SOP, or a non-standard SOP to a standard, is the fact that when I take a variable and I OR it with this self, I get a 1. The other rule that we make use of is the one that says if you take a variable and you AND it with 1, what do I get over here on the right side of the equal sign? If I AND a variable with 1, what do I get? If I AND the variable with 1, well, it depends on what. If A is a 1 and I AND that with 1, I get a 1 over here. If A is a 0 and I AND that with 1, I get a 0 over here. So it looks like that whatever the value of A is for either case, that's what I got over here for my output. So basically, if I have A and I got that with 1, then what I'm going to get is whatever A is. And so we make use of that rule, the one that says if I have a variable and I AND it with 1, then I get whatever that variable is. It doesn't ANDing it with 1 doesn't change the value of it, in other words. And that should make sense to everybody. So how are these two rules going to help us? Say take this standard, this is a non-standard SOP. How's it going to help us to convert this to a standard SOP? Well, let's go through it and then you'll see. So the first thing I want to do is list out the domain. And I see domain here is ABC. And there's a D. And I see this is a non-standard because I'm missing the D from here, and I'm missing a C and a D from that term. So I have a non-standard SOP. I want to convert to a standard SOP. So I'm going to start with this term. So I'll write that out. And what I'm going to do is, if you think about this right here, this works for individual variables, but also works for the whole term. In other words, if I AND this with the 1, then what I get back is A bar B bar C. ANDing this with a 1 doesn't change anything. But it doesn't matter if I AND it with a 1 like this or I AND it with a 1 like this. We can do both sides of this equality. They're the same, so it doesn't matter if I use this one or this one. We're going to use this one, because that's going to help us to put what we need in there. What we're missing is a D. And so according to this, I just change that from A's to D's. If I take D, which is what's missing from here, and I OR it with D naught, if I take D or D naught, I get a 1. If I apply this, that means I can actually AND this with the 1, or I can AND it with the D or D naught since they're equivalent. It doesn't change the logical value of it. So I want to choose to AND this with what's missing, and what's missing from that term is D or bar D. And then you just do what you think. You just expand this, and you end up with 2 additional terms. So if we expand it, what I get here, say green, I get A, B, C, D, or A, B, C, D. These are knotted. And when I go to this one, that's knotted. So basically, this one term, you can replace with these 2 terms right here. And you haven't changed the logical value of the expression. So, if that makes sense, does anybody have any questions before I move to the next part? Everybody see what we did? It's pretty simple. But I just want to make sure that I'm clear what I'm saying.
I might have missed something, but why did we put a knot over the A when we started doing everything else?
You mean over here?
Yeah. So like it's A, B naught, C, but then you wrote down A naught, B naught, C.
No, that's me. You don't
Okay,
know
okay.
what. No, it's not
I want
you.
to make sure. I was like, what's going on?
No, and I'm glad you said something because I'm like, I mean, is anybody out there? Nobody's answering my question. So I could say I made that mistake on purpose to get you to talk, but I'd be lying. So he's right. So some kind of way I added an extra, but I mean, the logic still applies. You can see. But for me to be correct, I added the A. I don't know why I added that A. And so let me just get rid of that, just so we're 100%. So what I should have written, thank you, whoever was pointing that out to me. But at least it got you to talk. So I got a bar here, a bar here, and a bar here. And that is the thing, guys. Honestly, as these get bigger, it's easy to make a mistake like that. It really is. And then if you go through the whole process of what we're going to do over the next couple of days, so you do want to go back and double check like that, to go back and make sure you didn't leave a bar off or add something inadvertently or whatever. But what I was trying to say is that this one term, since this is logically equivalent to it, you can replace this with this, and you haven't changed the logical value of the expression. So what I want you to do is I want you to do that same thing to this next term. Now, when you do that, don't try to, obviously you're missing the C and the D, right? You're missing the C and the D. So when you do this, don't do the C and the D together. First, go through and multiply by C or C bar like that and expand it. You'll get two terms. And then with those two terms, you got to multiply them by D or D naught to expand, to finish the expansion. So don't try to do the two together. Some students want to jump the gun, and that'll screw you up. So just do one variable at a time and go ahead and expand this. And then while you're doing that, I'll go ahead and rewrite this on the board. So apply what we just talked about to that second one, and then we'll end up with our standard SOP. So I'll give you a minute to do that. So I did the first expansion. I'm trying to get a C into here. And so I multiplied by C or bar C. And what I got is this, not A, not B, C, or not A, not B, not C. And now we're going to do the same thing with these two, expand those, but this time we're going to add a D. So go ahead and add your D. Then when I do that final expansion, I end up with not A, not B, C, D, and over here, not A, not B, C, not D, and down here, not A, not B, not C, and then I end up with D, and then the last one, all the terms are knotted. So how does that compare to what you guys got? Did I do it correctly? Does that square off of what you got? I think it looks all right.
But I
In
got
the end, you want to put all these together, and so I'll just write them up here, but I want to show you one more thing. I got that one. That one. That one. And that one. So that's what I end up with. Okay. Any questions so far? Okay, well then let me switch back over to the handout, and I want to talk about something else. We'll come back to that in just a second. So I want to go down here. Oh, by the way, on this handout, everybody on the handout, problem number 3 on this handout is your final quiz. Quiz number, I think you did quiz 10. Quiz 9. Yeah, we're on quiz 10 now. This is quiz 10. So make a note of that. I think I have this posted already on your Canvas. But basically, you're going to do what we just did. You're going to take this expression and you're going to convert it to standard form. So just, I think it's posted on your Canvas. I'm pretty sure I activated it. You'll see. What it refers to problem number 3 was problem number 3 on this handout. So just make a note to yourself that this is your quiz 10. And that's going to be the last quiz of the semester. I won't give you any more after this one. But anyway, look at problem number 1 and 2. So problem number 1 and 2. So what you want to do for problem number 1, basically that is a very, very simple. You have these sum terms and you have these product terms. So the sum terms always evaluate, by definition, they evaluate to 0, and the product terms, by definition, they evaluate to 1. So what I want you to do for these first two problems is give me the value of A, B, and C to make each of these true. The value of A, B, and C to make each of these true. So I'll give you about a couple minutes to do that, and then we'll talk about it.
You're muted.
I don't know why I muted that. Okay, so what I was trying to say was I have a sum term and I have a product term, and we said by definition, a sum term is going to evaluate to 0, and a product term is going to evaluate to 1. So what I want here for this, you need the value of A, B, C, and D to make this statement true. So in order to make this true, A needs to be a what? A 1 or a 0?
A 0.
This needs to be a 0. But B needs to be a what? B needs to be a 1. A is a 0. If I make B a 1, I'm barring that B, which is going to change it to a 0. So now that one there is a 0. So A needs to be a 0. B needs to be a 1. C needs to be a 0. And D needs to be a 1. Everybody see what game we're playing. See what we're doing. What's important, though, is this one over here. In order for this one to be true, give me the value of A, B, C, and D to make this product term true. A needs to be a what?
A 1.
A needs to be a 1. B needs to be a 0, because I'm not in it. C needs to be a 1. And D needs to be a 0. If you put the value in A, B, C, and D into that expression, it will evaluate to a 1. But notice something, that you can quickly get this value if you just look at that term, and any variable that's listed in the term, just write that as a 1. And if it's a complement, write that as a 0. So I got a variable, complement, variable, complement. So what I can do, instead of thinking like this, I don't even want to have to think about it. I can say, all right, that's a 1, that's a complement, that's a 0, that's a 1, and that's a 0. And then I got the value, the binary value that will make this true. But I also have a way of linking this term to a row in the truth table that I'll show you here in just a minute. So I call this the binary value of each term. You can quickly do it when you're dealing with a product term. You can quickly do it by just writing any variable as a 1 and any complement as a 0. So I want to do that for that whole expression up here, the one we just solved, the one we just expanded. So this is a 1, 0, 1, 1. That's the binary value that will make that term true, make it a 1. This is a 1, 0, 1, 0. This is a 0, 0, 1, 1. This is a 0, 0, 1, 0. 0, 0, 0, 1. 0, 0, 0, 0. So you put those values in to those expressions, and then this whole thing would equal 1, or any individual term would equal 1. Okay, so, well, how would you connect this to a truth table? You got to connect this to a truth table, and then connect the truth table to a K-map. That's kind of where we're going. So that's the other example on the handout. Let's look at that one. So that's problem number 4. It says, develop the truth table for the standard SOP expression. Well, now you know why we have to have our SOP in standard form, because what we have to do in order to use this for your PLC or just logic in general, what we got to be able to do is put it into a truth table, but there's no way to put a non-standard SOP into a truth table, because in the truth table, you have to have a representation for every variable, every literal. So you got to, that's the reason for making it a standard, a non-standard into a standard. So what we want to do then, to do number 4, is you want to draw out your truth table and then write the binary value of each term, and then the numbers in the truth table map directly to each term. So step 1, go ahead and draw out your truth table. You got to know how many rows to use for the truth table. And then the next thing you want to do is write the binary value for this expression I just circled for each term. And then since we know that each term evaluates to a 1, well, basically the binary value for each term is pointing to the 1s in the truth table. Now, if you don't follow what I just said, it's okay. Step 1 is to, you need a truth table. So get a truth table. You have 3 variables. Draw a 3-variable truth table. And then the next thing you want to do is write the binary value for this expression for each term. So let's start with that. So when you're making your truth table, you want to remember that in the truth table, the number of rows is 2 to the second, or I'm sorry, 2 to the nth power, where n is the number of variables you have. So we got A, B, C, we got 3 variables, we need 8 rows. So I'm going to design my truth table with 8 rows. And I gave you a real easy way of writing out the value for each row of the truth table. You list your inputs, and your output. You're going to count here. We want to count in binary. So if you make all your inputs on the very first row 0, and then what you want to do is you want to alternate for this, the one closest to the output, you want to alternate every other bit. We got to do it 8 times. So the first one is a 0, so this is a 1, 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. So the first one closest to my output, I'm going to alternate every bit. And then the next one, I'm going to alternate every 2 bits. So this is 0, 0, 1, 1, 0, 0, 1, 1, and then every 4 bits. And if I had another variable, another column, it'll be every 8, 16, 32, 64. It goes by powers of 2s. So if you do it that way, you're doing 2 things. Number one, you're counting in binary, right? 0, 1, 2, 3, 4, 5, through 7, binary. And then we're all going to end up with the same results because we're numbering our truth table rows the same way. Well, then what you do is you get the binary value of each one of these. So this is a 0, 0, 1, 1, 0, 0, 1, 1, 1. And basically this points to a row in the truth table. And you know that because this is a product term, that evaluates to a 1. So what you're saying by doing this is that at row 0, 0, 1, you have a 1 right there. There's a 1 here. Right here at 1, 0, 0, you have a 1 right there. So there's a 1 right here. There's a 1 at 1, 1, 1, there's a 1 there. And all the other unmarked rows are where my zeros happen. These are all zeros. Normally when I'm doing this, I don't show the zeros. Sometimes I don't show a complete table. We're really only interested in the 1s in the truth table. So it makes it look a little simpler if you don't put the zeros in there. But if you want to be complete, then you would show the zeros. The other thing to note, and you don't really have to know this right now, but so this is the truth table that represents this expression, but each one of these terms you can write it that way. And what I'm saying is I can say I got A, B, C. Given the truth table, you can go backwards, right? Given the truth table, you can go back to the expression. If I go to where my 1s are, A, B, C, so since these are zeros, I know I got a bar there and a bar there. Or like right here, since these are zeros, I know I got a bar there. So given the expression, I can get the truth table, or given the truth table, I can go back to the expression. And I can get the opposite expression of this. So this is a SOP for this truth table. Well, I can get a POS from this too. It's not useful for what we're doing, but you can actually do it if you wanted to. Because remember, the SOPs are where all the 1s are in the truth table. The POS, those are the zeros. So this is actually a term of a POS. So if I wanted to do it, I can say A or B or C. And since these are all zeros, I can put bar, bar, bar. Or down here, A or B or C. I got a 0 here and a 0 there. So that's a bar and that's a bar. So given the expression, you can get the truth table. Given the truth table, you can get the expression. And it turns out, and I didn't really say this last week, but not only can you represent the expression as a truth table, or a truth table as an expression, once you have a truth table with an expression, and again, to get that, it's got to be in standard form, You can also put this into a K-map, which is what we want to do next. We want to put this into a K-map and see what that gives us. But we want to apply it to some practical problem. And that's what we'll do in the next class. So that's all I have for today. Does anybody have any questions for me? Anything we did so far, anything in general?
I got a question about exam number 2.
Okay.
The due date is August 14th.
Is that what it says?
Yeah, is that? I thought the the last day of the semester was the 9th, and like grades.
Is that true?
That's what I thought. I don't know. I could be wrong.
Yeah,
Okay.
the last day is August 9th.
It is the 9th?
Yeah.
Okay. Well, I'll have to adjust that. It doesn't hurt us either way because we'll be done before the end. I was just trying to give you as much time. I thought I had the 26th, though. I don't know why I had the 26th. I'm doing too many things, guys. I'm 2 or 3 different schools, and it's just crazy. So I'll have to thank you for pointing that out. I'll make an adjustment. It doesn't affect us either way because we'll be done. So I'll just change that to the 9th. And since you brought it up, I highly recommend that you guys go ahead and get that out the way. While that garage door program that you did for the lab is fresh in your mind, go in there. Don't wait to the last minute to do it. It's not that difficult, but it might take a little bit of time. So I will go ahead and it's easier for me because I got a grade. It's hell to grade this stuff. You guys might imagine. I got to go through all these programs. So, but this one you're just going to demo it for me. You're going to demonstrate it. So go ahead and get it out the way. It'll be one less thing on your plate. You know, in the next, if you're not too busy, maybe in the next couple of days or on the weekend, get that exam, get your 100 points. Good for your GPA. Get it out the way. And then the only thing you really got to worry about is exam 4, the final exam, because this stuff here, if you can follow what I'm doing in class, in the next 2 exercises I'm going to give you the next couple days, and then we'll start to implement some actual designs based on what we do. If you follow everything, I guarantee you'll do well on exam 4. It's not an issue. So go ahead. You know, I don't want to put any pressure. I know you guys are really busy. I know you got a tough class before my class, but if you can, just try to get exam 2 out the way. You know, it's not that bad. And then you won't have to worry about it, and then we'll just focus on this stuff, and then I think everybody will be happy. So I'll make that adjustment. Thank you for pointing that out to me. Anybody else have any questions or comments before we sign off?
Did you say when the final was gonna be? I don't know if you said or not. I might have missed it.
The last day. I just save it for the last day or the
Okay.
last weekend. Even when the semester's over, I think we have what day is the 9th? Anybody have a calendar handy? What day is the 9th?
It's a Monday.
So they usually give us 3 or 4 days to get our grades turned in. So I can make the final due anytime. I like to give you a weekend to do it. And it's just, it's something like you'll download. It's not anything. It's not one of those multiple choice things. It's not that. It's something you'll download, a document you'll download. And if you have all the pieces of the puzzle that we're going through, like the last couple lectures and today, and then what we'll do the next 2 days, you'll have all the pieces right there. So literally, you can take what we're doing. You got all those pieces laid out. You should be able to work your way through that final exam with no problem. So it's something you'll print out, and then I'll make it due on the last day of class. I just don't want you to have too much. I know some of you you kind of wait till the last minute. So I don't want you to have the final exam 3, which is not hard at all, but you got to do some digging for exam 3 and some research you got to do. And then exam 2, I don't want all that at one time. So that's what I'm saying. If you get exam 2 out the way, you don't have to worry about it. And then you can just focus on this stuff. Okay, so I'll get in there and make adjustments to the dates. And then make sure everybody's on par. I think everybody's doing okay. I do have one student. I don't know. I didn't look at the names of, but I have one student that I'm concerned about. But I'll contact that student individually. I haven't gotten hardly any work from just one person, but everybody else is doing okay. So yeah. Any other questions or comments? Okay. Well, if you do have a question or comment, you can text me. But for the next class, guys, the documents, I don't know if I have them activated. I'll make sure they're activated here after this class. But you want to print those out and have them in front of you for the next class. So between now and Wednesday, print out the documents that are live on your Canvas. in this module, and then you'll have it and you can write on it. And I think it'll make things easier. It'll make it a little easier for your final exam if you have these papers handy. So guys, have a great rest of the day. I will see you on Wednesday. Anything comes up, just send me a text and I will respond to it. Thank you.
Have a good one.
Thank you so much.